Hello, Math Apps students. Today we're going to be talking about combined probabilities using diagrams and the laws of probability. We're going to be focusing on this kind of picture for this whole lesson. So if I see this upside down U, this is talking about events A and both occurring. This is called an intersection. And so whenever you see the upside down U, you're going to be talking about the intersection, which basically is the football region here in the middle, which is the intersection of A and B. Now, if you see the U between the two things, that's saying that we have the union. So it's either going to be an A or B or both. So if it's a union, then basically we are shading everything inside A and everything inside B. If we see A prime like this, that means shade everything that is not in circle A. So basically everything outside of circle A is what we're talking about. Okay? And then lastly, probably the most challenging for many students is this one here. This is saying event A happens given that event B occurs. So because we're given that B occurs, then we only are concerned with being inside B. Okay, given that event B occurs. Now the thing is, we want to find the probability that A happens given that B it happens. Basically, we are looking at only the blue portion divided by the whole circle B. And we'll be talking about that in some future examples. Okay? So let's look at the next example. Okay. Some students are chosen at random. If E is the event the student takes ESS, G is the student takes geography, find the probability that of the intersection. So let's do the first one here. Here's the upside down U, that means intersection. So the intersection of circle E and the intersection with circle G is the little green section there. And there was a 1 there, so basically we would say the probability of E intersection G is going to be equal to 1 over the total number that's there. And if I add all these together, the 2, the 2, the 3, the 1, the 3, our total is equal to 11. 2 plus 2 plus 3 plus 1 plus 3 is 11. So this intersection is 1 over 11. Okay, now let's do question B. B talks about the union of E and G. So the probability of the union, oops, let's write that again. E union G. Okay, so that refers to anything inside here and inside here. So I've got 2 plus 3 plus 1 plus 3 all over our total, which is 11. Okay, 2 plus 3 is 5, and 5 and 4 is going to be 9. So we end up with, this is equal to 9 over 11. Okay, and you just leave your answer as a fraction. As you know, probabilities are between 0 and 1. If you get an answer greater than 1, then that doesn't make sense for probability. Okay, now the question C says E prime. Okay, that means not inside E. So if we look at circle E, And if we're not inside circle E, then basically everything outside of the circle, right? So everything outside of the circle is the 2 and the 3. So the probability of E prime is equal to the 2 plus 3 over our total, which is 11. So this answer is equal to 5 over 11. All right, and then lastly, let's look at this next example. If we have, they're asking the probability of E given G and the probability of G given E. Those are different answers. So the probability of E given G says, okay, we're looking inside circle G, and given that it's E is the 1 here, and inside circle G, my denominator is 1 plus 3, which is 4. Okay, let's think about that for a second. Given that we're in circle G is right here, right? And what is the probability that you are E given that you're in circle G? So the only thing that matters in your world is the yellow circle. And we have a 1 here and a 3 here with added together, which is why my denominator is 4 and not 11. If you have trouble with this, you might want to replay this again to see how you're going to do. Okay. Now I'm going to do the other one up here because I've already colored this picture. So in this example, I'm going to do probability of G given E. Okay, so if I'm doing the probability of G given E, this time we're saying, okay, given that you're inside circle E, I'm highlighting circle E. Okay, our world only consists inside the yellow circle. What is the probability that you are also in circle G, given that you're inside the yellow circle? So this region here is region G. So this is region G inside circle E, given that we're in circle E. So my new denominator is 2 plus 3 plus 1, which adds up to 6. So my denominator is 6, and the intersection of G and E is 1. Okay, so you may want to play this back again to see the difference between this one and this one. All right, next example. Okay. Okay, probability that you're in A is, okay, let's find out our denominator. We have 3 plus 4 plus 5 plus 6, right? 6 and 4 is 10, and 3 and 5 is 8, so we've got our total is 18, right? Okay, so the probability in circle A is 3 plus 4, which is 7, over our total, which is 18. The probability of not in circle A, okay, so we're not in circle A, is 5 plus 6, which is 11 over 18. If I have 7 over 18 plus 11 over 18, we have 18 over 18, which is equal to 1. Interesting. All right, probability in circle B. Okay, here's circle B. 4 plus 5 is going to give me 9 over 18. The probability of A plus B. Okay, circle A is 7/8, 7 over 18. Probability of B is 9 over 18. If I add these together, I'm going to end up with 16 over 18. Okay. And then next we've got the probability of A union B, which is, oh, sorry, this is intersection. Oops. Okay, there's something wrong here. 3 plus 4 is 7. 4 plus 5 is 9. And then with the 6, 9 is 18. Something. Okay. A intersection B is just 4 over 18. And, oh gosh, no. 4 over 18 is the intersection. Union of A and B is 3 plus 4 plus 5, which is going to give me 9, and 3 is 12 over 18. And probability of A plus probability of B minus the intersection. Okay, so probability of A is this, probability of B is this, so we get 16 over 18 minus the intersection, which is 4 over 18, which is going to give me 12 over 18. Interesting. This and this are the same. This will come back. We're going to talk about this relationship. Okay. Oh my gosh, these circles don't overlap. Let's look at this. Probability of A is 3 over, 10 plus 3 plus 6 is going to give me 19. My total is 19. Okay. Probability of not being in A is 6 plus 10, which is 16 over 19. Okay. If I add these two together, we get 3 over 19 plus 16 over 19. That's going to give us 19 over 19. Wow, that adds up to 1, doesn't it? Okay, probability of B is 10 over 19. Probability of A plus probability of B. So 3 over 19 plus 10 over 19 is going to give me 13 over 19. Alrighty. A union B is 3 over 19 plus 10 over 19, which is also 13 over 19. A intersection B, there's no intersection, is there? So that is 0. Okay. Probability of A plus probability of B minus the intersection. A plus B is going to give me 13 over 19 plus the intersection, which is 0. It's going to give me 13 over 19. Okay. If you have trouble with these relationships, you may want to hit pause or play it again. Okay. Let's do this bottom one and then move on. Okay, so we've got probability of A, probability of not being in A. Okay, probability of A. We've got 3 plus 5 plus 10 and 6. So my total is 3 plus 5 is 8. 18 plus 6 is 24. Okay. So the probability of being in A is 3 plus 5, which is 8 over 24. The probability of not being A is 6 plus 10, which is 16 over 24. And the probability of A plus the probability of not being in A, let's see, these two added together is going to give me 24 over 24, which is equal to 1. Okay, probability of B is in this circle. So 5 and 10 is we have 15 over our total, which is 24. Okay, the probability of A plus B That goes here, so probability of A is 8 over 24 plus the probability of B, which is 15 over 24. And if we add those together, we get 8 plus 15, which is what? 23 over 24. Okay. Now, the union of A and B is 3 plus 5 plus 10, which is 18 over 24. The intersection here is going to be 5 over 24. And then lastly, the last here is the probability of A plus the probability of B minus the probability of A intersection B. And I want you to notice this is an important relationship. Probability of A is 8 over 24. Probability of B is 15 over 24. And the probability of the intersection of A and B is, we're subtracting that, is 5 over 24. Okay, so 8 plus 15 is 23 over 24. And if I subtract 5 over 24, what do we end up with? You're right, 23 minus 5 is going to give me 18 over 24. Now in both of these examples, in all of these examples, this and this is the same. And this right here is the probability of A union B. And it works in all of these examples. The probability of A union B is the same as the probability of A plus the probability of B minus the intersection. So let's ask ourselves these important questions. What is the relationship shown in column 3? Column 3, oh my gosh, we got 1, 1, 1. So the relationship in column 3 is the universe, which is the probability of happening plus not happening which is equal to 1. 100% going to happen. Okay, why is this always true? Because if I add everything inside A plus everything outside of A, it's always going to add up to 1 when I add up those two probabilities. Okay, what is the relationship between 6 and 8? We said that they're the same, right? Why are they the same? Okay, super important. Now, why are they the same? Here I've got the union, but we don't want to count this part twice. That's why if I take probability of A plus probability of B and subtract this intersection part, that gives us A union B. Okay, so this relationship is true because we take the probability of A plus the probability of B minus the intersection of A and B, because we don't want to count this part, the center part, twice. Okay, you may want to pause and think about that for a second, or replay that. Okay, how can you tell that two events cannot both occur? Okay, if two events cannot both occur, that means that the circles don't overlap. Circles don't overlap. Okay? And which class shows mutually exclusive? This happens when the circles don't overlap. Okay? And for which class can the relationship you wrote for question 3 be simplified? Let's think about that for a moment. Okay, let's answer question 8. Okay? So, complete the table to the summary and justify what you've said. Okay, so the union of A and B is equal to the probability of A plus the probability of B minus, what did we have to subtract? We have to subtract the intersection of A and B minus the probability of the intersection of A and B. And that's always going to be true because we don't want the intersection to be counted twice. Okay, the intersection of A and B is equal to 0 when the circles don't overlap, and this is called mutually exclusive. So if your circles don't overlap, it's called mutually exclusive. Okay, and therefore A union B is equal to the probability of A plus the probability of B when it is mutually exclusive. Right? Because I didn't have to subtract the intersection, because if I've got A here and B here, if I add those together, that should give me the union. Okay, so let's summarize things. Two events, A and B, are mutually exclusive if they both cannot occur. Like here, they can't occur at the same time. So knowing that A occurs, you know that B cannot occur. Okay, and this is saying that the intersection of A and B and the intersection of B and A is going to be 0 because they don't intersect. Complementary events, when A and not B and A are mutually exclusive, and they're always going to add up to 1. This should be everything you need to do your homework on page 324, 7F, numbers 1 through 4. Good luck, Mustangs!